we will be talking about this project, which is a mass timber and pre-manufactured light frame hybrid approach. So this project is located in Big Sky, Montana, and is a 7,700 square foot home designed by Reed Smith Architects in Bozeman. Peter Bing of Blue Ribbon Builders in Big Sky is the general contractor, using Stolz Timber and Haslacher for CLT supply. And Pat Clark from Stolz Timber is actually here tonight and will talk a little about CLT, and he will be available for questions later as well. So Collective Carpentry is the manufacturer of the light framed panels, and they are also going to install the mass timber, the light framed components, and wood load path members, as well as insulation and membranes. The engineer of record is Madden and Bauman Engineering from Portland, Oregon, and Tom Bauman is also here tonight and will speak about this coordination effort. He was supported by Fire Tower Engineer Timber. And then Eric Renner of Central Plumbing, Heating, Excavation in Belgrade, Montana, is the extremely competent MEP engineer who unfortunately can't be here tonight. And then there is us, Holzraum System, and we are making sense and coordinating all of the information through a single integrated manufacturing model. So yeah, I'm going to explain briefly who we are and what we do, and then Steve is going to walk you through a live SIM model. So this is us. I'm an architect, CPHC, and energy modeler. And Steve is also a CPHC, a structural designer, CNC programmer, and high performance builder. And David is a biologist and software designer. And I kind of like to introduce us to show that we are coming with a pretty diverse list of backgrounds, which explains to some degree why we are doing what we're doing. So yeah, Holzraum System works early on with the project team to align all perspectives with factory-specific construction and prefab and preferences. The goal is to coordinate and translate design intent into what will be fabricated and assembled. We are independent and partner with several manufacturers, and because of that, we had to develop a communication strategy that is actually universal in terms of manufacturers' outputs, as well as a tool to communicate and collaborate with all stakeholders. And we call this tool a single integrated manufacturing model, or SIM. The SIM actually develops into a production fidelity SIM model and generates panel shop drawings or machine file outputs, as well as raising and installation instructions. So the outputs can actually be used by local labor force to build panels by themselves, or by highly automated factories. But yeah, either way, we are part of the team from design development to the end, to installation of the panels. So to explain this a little further, here is the Revit model that we got from Reed Smith Architects. And as you can see, it's great at showing design intent, convey basic construction strategies, and explain spatial relationships. And it is a volumetric model. And these are the outputs from a volumetric model, and they are really great for documentation of plans, elevations, sections, window and finish schedules, and lots of other things. So Revit is great for the architect, right? And engineers as well. So a SIM, on the other hand, is an expansion of what you need to manufacture the panels. So it's a precise parts-based production model. In a production model, every element that makes up a panel needs to be identified, modeled, and organized in order to generate these outputs, like 2D geometry review set, site prep coordination drawings, installation drawings, panel shop drawings, and in many cases, machine files. So we started thinking that there's just so many lost opportunities in just using this parts-based model for production, because you have to build this model for production. Otherwise, it's not going to work. So you have this. So, and this is what typically would be modeled by the manufacturer. In this case, the interior walls, the exterior walls, floor panels, and roof panels. But since we know that what is being built in the computer will be built exactly according to instructions in real life, we started to include other perspectives. So this is the load path, and the Revit model of this was actually provided by the engineer with correct sizing of the members, but it needed to be organized and integrated into the rest of the model. And the same is for the foundation. So the MEP model was also provided by the engineer and could be integrated and clash detected. So, by kind of running through this with all the other elements, we can check against all of everything that's being built. And then we also add windows and doors, and this actually came out of the architect's Revit model. And then we work with the architect builder to integrate them and really detail them out. And this is what we call a holistic parts-based model. And then in this case, we also were asked to integrate the terrain model, which was provided by the excavation contractor. So we started using the SIMM as a communication tool for field and trade coordination, for high performance envelope detailing and instructions. And the SIMM basically becomes a visual database that feeds an information log. And it has endless possibilities to attach data to each part. And then it can be exported into lists that become available to the builder. And Steve is going to talk about that more in a little bit. So the SIMM, becomes an accessible database even beyond the building's life cycle, and could be integrated. That's kind of our dream, that it actually could be integrated into the circular use and reuse of building materials, because everything is accounted for. So everything is in a database. So, eventually when we really have to go back and using sustainable materials is actually not good enough anymore. We have to use what's already there. There's already the database available where we can see how much of what is there and where it is. So on this particular project, we were really excited about that we could develop a true hybrid system and or hybrid of systems that came or that are coming from different manufacturers, and that we could be the coordinator between all of it. And now I am happy to introduce Pat Clark, who actually built the first commercial CLT building in the United States. And he is actually a walking CLT encyclopedia. And he will be talking about mass timber systems and why we ended up using this hybrid approach.
Thanks, Ilka. So a brief introduction as to who Stolz Timber Systems is. We're located in the Flathead Valley of Montana, northwest Montana, up by Glacier National Park. And my company, Wooden House Supply, which has been importing European timber products since 2009, merged or formed a joint venture with a 109-year-old sawmill here in northwest Montana that owns 40,000 acres of its own timberlands that has been sustainably managing them for over 100 years. So we formed a joint venture to start to manufacture our own line of what we call CLT 2.0 products here in the Flathead Valley. And where this all started for me was I had met a colleague through a German contact who actually worked at the first CLT business in the world. It was in southern Germany, in Bavaria, a company called Merck Timber, which is actually still in business. And not that many folks actually know that. Most people think that the Austrians invented CLT, but in reality, it was sort of co-invented both in Bavaria and in a part of Switzerland, two separate companies sort of taking two different approaches to this product. What you see here on Ilka's slide is a combination of products, one or two of which are cross-laminated timber. And I think the important takeaway here is that mass timber isn't a group of products, but it's really a system approach to how you build buildings. So that's really, really important to understand, that when you're delivering a mass timber building, it could be a group of products that are all solid timber. It could be a group of products that are based on solid timber, but as you see on the right-hand side, there are timber boxes that could be open or closed and filled with say wood fiber insulation or cellulose to find the optimization between mass timber and high insulation values. So that sort of led me down this path of interfacing with several European suppliers and finding for each project the optimal product mix to fit with the project. And in this case, on this particular project in Big Sky, Montana, we decided to head down the path of CLT floor and roof elements in combination with high performance wall systems that are stick framed, prefabricated stick framed. And one of the reasons for that is that on many of these, say modern style houses, oftentimes the facade area is has a large amount of glazing or openings, windows, doors, etc. And it can be challenging to pull off those designs with a CLT wall system. And so on this particular project, we elected to use CLT where it's very strong, which is floors and roofs, and you go with the prefabricated light frame high performance wall systems. One of the other things that I wanted to mention is that for you folks in the passive house community, it's quite common for cross-laminated timber as a system to be utilized in passive houses, primarily in Europe to this point in time. But a colleague of mine in the UK actually constructed the tightest passive house that was ever built in the United Kingdom, and the entire building was cross-laminated timber. So yeah, with that, I think I guess I hand off to Steve.
So this is the Montana project that we're talking about. Let's see. So really quick, I'm going to kind of show you just some of those components that Ilka talked about that are brought in, either created by Holzraum or many times brought in. So it's content that comes in and goes back and forth many times, sometimes because like for instance, the MEP information, it's like you're finding clashes pretty early at a course level, and then you're starting to evolve, and the architect's still working on stuff, and structural engineer still working on stuff, and then the MEP. So it's super iterative. And so for us, what we're actually trying to do is figure out, this model is quite huge, and luckily CADWork has this cool feature called Team. So the MEP is actually is referenced in. So right now, this is actually not in the model. It was in the model for a while. It was in the model for a while, and it was better that it was in the model for a while because it's not snappable right now. But when it was in the model, it was just a beast. It was an absolute beast, like 800 megs, this model is. But what's really cool is with team, you can start to break it out into different pieces, which we're going to be doing with Collective Carpentry, who I think Jan might be in the audience, but he's also a CAD work guy. And so when we're in production on the light framed panels, we'll be basically working, he'll have his piece and we'll have our piece, and we can update and exchange things. So anyway, there's, just the basic foundation, excavation model, load path model is all the blue is glulam, and then structural steel. There's all different types of sections that were given to us by Tom Bauman, and who's going to talk in a few minutes. And the structural engineering stuff that came from Bauman, Madden and Bauman was just awesome, because usually it's quite representational from a structural. Well, first of all, most structural engineers don't hand me an IFC file with all of their members. That doesn't usually happen. Second of all, if it does happen, it's almost never sized correctly. So what was awesome is these things were all sized accurately. And I just had to, I always have to nudge them into the right alignment and location, but it was really, really good. So we had a lot of back and forth, and then we were able to work through connections kind of together a little bit. But those guys mostly handled most of the connections here, which we're going to get into a little bit more too. And then we have exterior walls, and these all are panelized right now. So that's a panel. You can basically pull these apart, but they're not in their final panel configuration yet, because we're about 2-3 weeks away from kind of handing off for production. And then interior walls, and this is the CLT floor panels. So they're all 180 millimeter, about 7¼ inch CLT panels, with all the penetrations that can be pre-cut if it makes sense. So we work with the MEP on that, and then the roof system. So what I'm going to do is, I'm going to peel this roof system apart. I really am very excited about this roof system, but before I do want to see if Tom can just talk a little bit about their company, and like what this was sort of like for him. I'll just leave the screen up, Tom, and then you can just go ahead and unmute and tell us a little bit about yourself and about how this worked out.
Yeah, sure thing. Hi, everybody. I'm really happy to be invited, and I'm excited about this program today. My name is Tom Bauman. I'm structural engineer in Portland, Oregon. Our company's been around. I've been practicing for about 25 years, and this company, Madden and Bauman, I think we're in our 16th year together. We work on a pretty wide variety of projects, commercial and residential, everything from custom homes like this to some fairly good-sized multifamily projects. And like a lot of people in the area, we feel like we're pretty tuned in with wood construction, but there's a lot of really exciting advances that just like all of our competitors, we've been very interested in getting into them. And we're kind of pleased to see some of the mass timber approaches, for example, becoming more cost effective as we all get better at doing it, and as there's more and more supply in the market. We had probably a common experience where it was hard to get some traction with these types of systems, because they were expensive and they were hard to source. But this project's a very exciting one for us, and it's been actually quite unusual for us. But that's primarily because of Steve's input on this project. So first of all, I guess if we're talking about the SIMM approach and sort of the approach that he's brought to the design, these CAD work models I think are kind of amazing, and have been incredibly instructive to help us see the building and sort of understand how these parts all go together. And kind of early on, I mean, I think that what we're most used to kind of a traditional design approach where we go through and kind of we're working in our own silo, probably communicating mostly with the architect, and we do our best to design and detail these systems. And on this project, the Holzraum and Steve in particular introduced this design process that was very unfamiliar to us. So the SIMM process meant for us that we were having weekly meetings, lots of discussions, both with the builder and with the other members of the design team. And really, unlike anything we've done on a project before, we were solving problems and doing the coordination in a really constructive way, throughout the process, instead of as a way of recovering from whatever things weren't coordinated in the design when we first put it out. So Steve and I were talking earlier about kind of when Revit and 3D modeling generally was first kind of discussed. I can remember people from Autodesk coming to us back in 2006, 2007, and sort of talking about what the dream of this software was, and that was that we would have these integrated designs and that everybody would effectively work together. And and frankly, I don't think that's ever really happened for us except on this project. So it's very exciting for us, and I think this model as a way to approach a project seems like it's something that we'd want to do again and again, because it actually has sort of created this like for us, like we're very confident that that things are thought out, that we think construction is going to go really smoothly, and I just think Steve has just been the hub of that effort, and really we're kind of looking at him like he's the star player on this whole process. But so one of the things that's kind of happened over and over again is that instead of us just taking a stab and kind of doing what we think makes sense, everything, literally down to the design of specific connections has ended up being a collaboration. So we just have a really high degree of confidence in this model, and we have a high degree of confidence that the build's going to go really smoothly, and this is going to go together quite well.
That's awesome, Tom. Thank you. And I swear to God, I didn't pay him for any of that. So you can just take my word for that. The beers are in the mail, Tom.
All right.
So no, it's actually really true that the collaboration has been just insane, and it's a bummer that Eric Renna from the MEP company couldn't be here, because Tom and Eric and Matt Schaefer, I don't know if Matt's in the audience. Matt's Tom's engineer, the project engineer. It's just been awesome, because it's hard to get people to, there's sweat equity in this, you know what I mean? Like Tom and Eric, and we always do, but they're putting a lot of time up front, and it's a weird thing. I mean, Tom probably was like, wow, this is a lot of time we're spending, but he also realized early on that it's way better to put this time up front instead of it being very difficult to quantify change orders and delays and sometimes really scary shit that can happen if you don't think it all through. And so anyway, I'm going to just show you an example of one of the collaborations that Tom and I and Matt worked on. So this roof is cool. This is a thermally decoupled 3-foot overhang, and the snow loads for this building are 160 pounds a square foot. So just take that for a second and think about the last time you designed a 3-foot overhang for 160 pounds a square foot. And the entire overhang is actually happening with this panel right here. This is what we call a static panel. But the static panel would be a tremendous thermal bridge if we didn't decouple it. And so Pat Clark actually kind of led the way on how he's been doing this for a while. And then we've kind of took it up another notch. But basically, if I peel this thing apart, we've got on the top, we've got 5/8 red zip. Okay. Take the red zip off. There's 2 layers of battens. There's the first layer is a 2x4 flat, and then there's a 1x on top of that, cross ventilated. And then I take the battens off, and these are the static panels. So all the static panels are here for the building. So they're handling all of the overhangs. But what's nice is they work out level and flush with this kind of top layer of Styco insulation. So next layer down, you can start to take the static panels off. This is the buildup. So this material is just like KVH material. It's awesome. It's going to come from Hauslocker. Everything that's going to come from Hauslocker is everything except for the insulation in this view. But this whole system of battens is going to be pre-cut, numbered part kit. And I'll get down where I can show you the part that is really exciting. So the way this works is collective carpentry is actually, so this is Styco Therm. Okay. Actually, let me go back. This insulation right here, this is Styco Universal Dry. This is what Ilka and I use on our light frame panels out here. And this is also what Collective Carpentry and Benson Wood and New Energy Works, we're all like drinking the Kool-Aid on this amazing exterior insulation. So because you can walk on it, it's waterproof, but it doesn't have quite the same R value. So what Pat has taught me is that you use that on the outside and then you use this stuff on the inside. It's got, this is like a 3.7 per inch and it's cheaper, but it's not tongue and groove. So it's excellent behind the other insulation. So we basically designed the spacing to handle structure, like all the spacing of this KVH build out, right? That's thermally decoupled. It's all spaced on European delivered sizes. So this panel is basically going to be cut in 2 out of the container, and Collective Carpentry is going to basically pre-prep these. So there's going to be a shop drawing for the installation. That way, when they come, they can just pretty much pressure fit, drop it in place. So if we could keep going down here and we start taking out some of the insulation, then you can see these basically this cross of KVH. The KVH material, by the way, it's cool. It's like a glue joint. It's almost like, if you had a piece of glue joint trim, but it's super straight and it's just as strong as solid. And it's actually, when we like build it into this whole Hauslocker package, it's actually cheaper than solid timber. So it's crazy. It's like it's kiln dried, dead straight, and cheap. So, okay, you figured it out. So then we go a little further down now. And now what I did is I wanted to show you how cool the level of fabrication that Hauslocker is going to do. So what we did is, if I make this guy, I'm going to just make him like a little bit transparent. You see the fasteners. So these are all rotoblast fasteners. And, with Tom's help and Pat's help and Fire Tower, we're basically finding the most cost-effective, optimal fastener through the massive rotoblast catalog. And then there's actually, attached to the fastener, there's a pilot hole. You see this little guy right here, the cyan guy? That actually is the guy that has the name and the product info on it. This fastener, the gray one, is just a design fastener. It's just there for us to communicate, for Tom and I and Matt to put it on drawings and just understand, what we're looking at, to have the parts in our hands. But this little guy right here takes up way less memory and he's got data attached. So right now, if I look at the data, I could fill every single one of these attributes if I wanted to, but the main things I have are that this is for the sequence roof system. It will be installed by Collective Carpentry. It is a rotoblast part. And then it is a TBS 10 millimeter by 360 millimeter. So basically that one part carries all that data. And what's cool is when it gets to Hauslocker, they're going to do for us is you see the little blue one is a countersink. It's only a 1/2 inch deep. So the countersink is going to get milled. And that little tiny part that's it's like 2 inches long is a tracking pilot hole. So that means that when the guys are on site, they're not thinking at all about drilling holes. They're just sticking screws into pilot holes, and it'll track perfectly because the angle has to be dead perfect, right? So like this fastener is designed, see that, like if you poke through it, if they went the wrong direction and they put a hole in the bottom of this very, very visible CLT roof that is their living room, we're screwed. So we can't have the screws screw us. So that means that we're relying on the manufacturer to basically just make it easy, but also dead nail every placement of every screw. But the cool thing is that because we have it in a SIM model, we have, every time we put a part in a model, it's basically a little bank for data. So it's just like, this whole thing is just a ridiculous visual data bank. So that's going on. And then what was the other thing I want to show you? This is cool. So this is all part related. This is Tom's connection. I love this. We were going to do this crazy ass like steel connector. We spent a week designing the wrong thing that Pat and I started on. And then Tom's like, why can't we just do a haunch like a timber frame? And I'm like, oh my God, I love a haunch. So that's basically what Tom did. Then Tom went and looked at the fasteners and found one that we didn't even know exists. And he cut the fastener frequency in half. So he saved us money on fabrication on the hangers. He saved us money on installation of the hangers. And these screws aren't cheap either. So what this thing looks like with these haunches, right? So that little tiny thing is an inch deep. That's carrying the entire CLT roof with the right fastener. It's crazy. And what it looks like when you take all of the parts out is this. So this is what will get machined. So these ridges have these pockets, and these are not just structural, but these are literally, that is the visible joint right there. So it has to be tight and clean and perfect, but we feel really confident that that's what will happen. Yeah, so then the other couple things, this shows the CLT structural members, really pretty simple stuff, right? I mean, it's just, it's all just rotoblast fasteners. We're trying to keep things as simple as we can as far as connections. Sometimes the connections have to get a little wacky, but a lot of the CLT stuff is pretty straightforward as long as you've engineered it out. So that's the roof stuff. And now I'm just going to show you a couple other little things about the model. So if I'm gonna peel it back. I'm gonna build it back up. So foundation detail, with like treated sill plate, we went back and forth a lot between the architect and Tom and Matt and I, because there's a lot of steps and things in here. And then this is all Tom's load path, Tom and Matt's load path. So there's very tight tolerances, because what's going to happen here is collective carpentry is coming from British Columbia, right? They're going to be down on this site in Montana with CLT from Austria, and they're going to provide these glue lambs with the joinery and the holes for like 3/4 bolts. So the coordination between this and the structural steel has to be pretty damn good. You can always say, well, I'm going to drill those, when I'm getting down there, but it is a time suck to do that, and it really can burn your budget. So we're going to try to do as much prefabrication as we feel safe about. And let's see. So we're bringing this is the load path with now the CLT floors. So you can kind of see what that looks like. And now I'm bringing in some interior walls, all the light frame. And this is all panelized as well. And you can see these weird rough openings. You're going to see that's all MEP. So there's rough openings for doors, but there's tons of rough openings for ductwork in this. So that's why it was like Tom and I had to really rely on Eric Renna to keep updating the MEP model, which he did a brilliant job with. And that you can see how that works. So basically all the framing, I don't actually even know how you frame these walls and put the MEP system manually, because when I was a carpenter, we didn't have MEP that looked like that. But I honestly don't really know how you do this like cost effectively. I don't know how that happens actually. This is the first project where usually our MEP coordination is through floors and roofs, but this is the first one where the walls was so intensive MEP coordination on this. So that's going to be nice. And then bringing in the exterior walls and then the roof panels. And that's sort of most of the building. I did this so you can just see, I just cut away the exterior walls a bit. So you can just see how having all those parts makes this just, really useful in meetings. So when we have coordination meetings, we look at the Revit models, but when we want to look at what's really going on in some of these spots, we can just turn on anything we want and get a little better look at things. This is the interior walls. So that's just interior walls. It is really nice to be able to just like turn on certain, scopes and perspectives against other scopes and perspectives and really zero in, and then, bring it all back. So yeah, that's pretty much it. I don't know if anybody has anything that they want to see in particular before we just start doing question and answer. If anybody has anything they want to look at, I can always bring it back up, but should we just, what do you think? Should we just maybe move into like a Q&A?
I think first, Steve, we have to pause the game and give you guys an amazing round of applause and a big cheers. Thank you so much.
Please unmute everyone and make a lot of noise.
Thank you.
I just made a passive house joke for you, Steve. I said, what does the SIM model say to Steve Hessler? You complete me.
Nice.
Little Jerry
Nice.
Maguire humor there,
So I'm gonna, I was just saying, I'm gonna unshare so I can see everybody's beautiful face. And then if anybody wants me to turn it back on, it's very easy to do that. Okay. So this is our, so we have all this data, right? And we're like, we can export, like CADWorks crazy awesome. You can export all these lists, but for years and years, it was always challenging because you pump out a list for bolts, right? And you pump out a list for timbers, and you pump out lists at sales, level, and then at development level. And it's just like lists all over the place. And they have these cool tools where you can save list settings, but I'm telling you, it's like a lot to like manage. And so we needed something that would do it all in one place. So we pump out a list at 3 or probably 3 different stages of the SIM model development. This one is our first foray into the production model. And so Collective Carpentry, Stoltz Timber's already using it for ordering. Haaslocker will use it. And then the guys in the field will install with it. So this is Catch, basically, these are different projects we have in here. There's project information. And then there's all these different types of reports. We also upload an IFC file of the project. So if you don't have CADWorks, you can get a free BIM viewer and you can see it right here. And every part in the model has the production. So this is a production number 646. So it matches everything in here. So if I wanted to go look for part 646, it's all in Catch. So if I go I can also, I can like filter by names. So remember I was looking at all those fasteners, those rotoblast fasteners. If I'm in the field or wherever I am, like I'm ordering or I'm in the field or whatever it is, and I'm like, I need to know about all the TBS8, this particular fastener. I now have all of those in front of me. If I want more information, I can turn on different columns. I can move the columns. I can sort right in among any of these. So let's see if I said, let's go back here. So I'm going to go to like roof system parts. This has all the parts that are in that roof system. So now if I want to see only the stuff that has, I only want to see stuff that it's insulation. So I can filter now, and now on the screen, it's just insulation. And then I can basically go down here. I can say download, and it took a second and a half, and now I have a CSV file of that report. So I can make all these different reports whenever I want. I can use this on a laptop or on a phone. And that way I can basically just get my hands on that data very, very quickly. David's probably like, you're not doing a good job of saying all the things it does, because it does a lot, but I'm still learning it actually. So anyway, this is the back end of the SIM model. This is where we're starting to figure out how to access very quickly and let the users, and the users for us are the panel companies, the builders, the installers big time, and the designers to some extent. You know, they all basically have a license to get in here and use that data navigation. So I am going to stop sharing.